Okay, let's do some cost curves. We're going to start with our production function and then derive cost curves from there. So all this is showing is our simplified firm, which is just something where we're going to take some inputs and we're going to turn it into outputs. So we're assuming that there is going to be one variable input, and almost always it's going to be labor. So sometimes I'll just label this as quantity of labor, but in general it's going to be some variable input, some input that varies with output. I'm going to need more of this to create output. And this is just showing me how much output I'm getting as I increase my variable input. So this is a simplified production, even more simplified, because I'm showing that right away output is increasing, but it's increasing at a decreasing rate. So in other words, I have diminishing returns right away to my variable input. I'm getting more output as I add input, but the addition to output is getting smaller and smaller. So I have diminishing returns right away as soon as I start producing. At some point I hit a maximum over here, and I showed that if I kept going, you would actually make things worse by keep adding my variable input. So basically the reason why we hit diminishing returns is because in addition to my variable input, we also have a fixed input. So for example, this is a simple farm, and I'm just going to add workers. My workers are my variable input. But my farm itself, the land, is a fixed input, so I'm adding variable input to my fixed input. My fixed input isn't changing, at least in the short run, and so I'm just going to keep crowding my fixed input. I'm not going to be able to get more and more output as I keep adding variable input forever. So right away it's the addition's getting smaller and smaller, and then at some point I would actually reach a maximum. I'm just going to keep adding workers to my land. Well, eventually they're going to run out of things to do and even make things worse. So that's at this point. Obviously I would never produce past this point, but I'm actually causing output to fall at that point. But in this simple graph, I'm assuming that because I'm increasing at a decreasing rate right away, that I've hit diminishing returns right away. So we can then go from this graph to our marginal product, or marginal product of labor, if I'm going to be using labor as my variable input. And so all this is the change in total product. So total product and output are interchangeable here. That's what I mean by total product. So this is just the change in total output as I change my variable input. So it's the rate of change, or in other words, the slope of this curve. So what's happening to the change in output? Well, I'm getting the addition to output is getting smaller and smaller. Even though I'm getting more output, the addition to output is getting smaller and smaller. The slope of this curve is getting smaller, and so that's what marginal product is. It's just the change in total product for a given change in the variable input. So I just drew it as a simple decreasing line. It doesn't necessarily have to be straight like this, but the point is that for this type of function, it's going to be decreasing. The rate of change of the total output or total product is going to be decreasing. And actually I didn't show it on this graph, but if I went past this point, the change would actually be negative, so I should actually be crossing this axis right at that maximum point, corresponding to the peak total product over here. Now normally we're going to have a slightly more realistic production function, which is going to look something like this, where in the beginning I'm going to have increasing returns to my variable input. So what's going on is I'm actually getting better in terms of producing output by adding an additional worker. The addition to output is getting bigger and bigger, and basically what's going on is, imagine I have a firm and I start adding my first worker and second worker and third worker. The second worker and third worker are actually making me more productive. We can start specializing, we have more division of labor, so the addition to output is getting bigger here. So imagine each unit that I'm going to add over here, the addition to input, I'm going to get a bigger and bigger change in output. So see over here where it's going to be largest, that addition to output. I'm going to have a large unit of output, or several units of output for a given unit of input. Then at some point right around here, this is my inflection point, where now I've hit diminishing returns. Right, so for this production function, I'm assuming in the beginning I have increasing returns. The addition to output is at first getting bigger and bigger. Then right around here, now it's basically equivalent to this. I've hit the diminishing returns range of this function, and now from this point on I've hit diminishing returns. So again, what's going on is that I've started to crowd my fixed input. I'm going to add more and more of my variable input, but there's only so much I can do for a given fixed input, and so I've hit diminishing returns. So you're always going to hit diminishing returns because we always assume there's at least one fixed input as part of my production function. And again, in the short run, something's always fixed. We'll come back later and talk about some long run issues, but in some short run, there's always going to be a fixed input that I'm going to be adding my variable input. So I can vary this in the short run. I can vary my variable input in the short run, but I can't vary my fixed input, and that means eventually I'm going to hit diminishing returns. So here I just assumed it happened right away. We're going to usually use this more realistic function where, at least in the beginning, I have increasing returns, then I'm going to hit diminishing returns. And then I didn't show it on here, but I could hit a maximum here, and then if I kept going, I'm actually making things worse by even crowding my fixed input even more, and then this might turn down. But essentially, this is going to be the important part of our production function. And then if I go from here to marginal product, well, the difference is now it's going to be rising and then falling. So remember, we already saw that when I have diminishing returns, the output is increasing at a decreasing rate, and that means the marginal product is falling, but still positive, right? Because output's still going up, it's just increasing at a decreasing rate. Well, now I just have this range over here where the rate of change in output for a given change in input is increasing. I'm getting more and more output for a given change in input, which means in the beginning, marginal product is rising. Then this point right here is where diminishing returns sit in. So this is the peak of this curve, and here I drew it as a curved line. It doesn't really matter so much for our purposes. You'll sometimes see it as just straight line, straight line. We're not concerned about the rate of change of this function, just the direction. So this is rising when we have increasing returns, and it's falling when we have diminishing returns. And then this would correspond to our maximum product, which again, I didn't go that far in this curve, but if this turned down, then that peak would correspond to this point over here. So this is normally the kind of marginal products that we're looking at because we're going to use this kind of function where we have increasing returns because of specialization and division of labor. In the beginning, adding more workers is adding more to output than the previous worker did, and then we hit diminishing returns. Okay, so now that we have that, well, let me add one more curve here. So we're going to add an average. We're going to have marginals, averages, and totals. So we have to make sure we keep it straight between these different concepts. We have a marginal change, the change of one addition, the last unit of labor in this case, or the next unit of labor, and I'm just going to start taking some averages of things. So the way I explain how we derive these average curves is take the first part of this curve, so we have this rising part of this curve, pick some quantity over here, and the marginal curve is telling me the last unit of labor had this particular marginal product. And then if I'm going to take an average up to that point, then I'm going to be averaging in all these earlier units which had lower marginal products. So whatever the average is, and I'm not trying to get this exact, I'm just drawing an approximation of what this curve looks like, but I know that the average would have to be lower than this point because I'm going to be averaging all these earlier units. So when I take an average product, which is just the total product divided by that quantity of input, I know the average is going to be lower. So I'm somewhere below this curve in this range, and I didn't draw it all the way, but pick any point over here, I know the average is going to be lower because I'm averaging in lower units since we're in this rising part of the curve. So now over here we've hit diminishing returns, we've hit peak marginal product, but this marginal is still above the average because if I were to go average in all these earlier units, the average would still have to be below it. In other words, the marginal is still pulling up the average. Whatever I'm adding for that last unit, I'm still pulling up the average. And the same is true here. So I've gone past that peak, I'm in the diminishing returns range, but when I go to average it in, that last unit is still above the average. I'm pulling up the average until now I'm falling enough and I sort of catch up with that average here. Right now the next unit that I add is now pulling down the average. And so the peak average product is gonna cross here. And so once I'm just going to add lower and lower units as I go over here, and I'm just going to be dragging down the average more and more. Right, so that's how we would construct this average product curve. Now this is not going to be as crucial for us as some of the other averages that we're going to see in a minute, but this still represents essentially productivity. So it's on average, how much is my variable input producing? So that's what average